All right. So in this module, we're going to talk about the labeling of phase fields and how to do that yourself when they're not always available. Okay. So what you'll find when you're looking at some phase diagrams that are reported is that not all um, phase fields are labeled. In this case, they are. So this is again the copper zinc phase diagram. And you'll see that all kind of every single region that you can see in this diagram are labeled. Even these small ones like this little tiny one over here and this one here, even they're labeled, but they're so small that they may have to use arrows to indicate where they're at. Right? So everything is labeled. So you know that if you're in this region, it's liquid, alpha, beta, beta plus gamma, right? So we know all of the regions. However, some of them will not. And this could just be from the construction of the phase diagram. They feel like they don't have enough space, or they just want to make it look cleaner without a lot of labels. We don't know exactly why they would do it, but there are some phase diagrams where, for example, only the single phase fields are labeled. So this is still enough information to be able to determine what all the regions are, but we're going to have to work a little bit for it. And so that's what this module is about, is how do we actually label those other regions, right? Because this is hafnium and vanadium. And you see it's a little bit more complex than a typical eutectic. There's an intermediate compound. But we know that up here is liquid. We know over here is vanadium. We know that this small region is hafnium vanadium 2. We know that the really small region over here that it's pointing to, so that means there's very limited solubility, but basically this little tiny sliver, that's alpha hafnium. And then hafnium also has another polymorph, beta, which is up here at the higher temperatures. And so that's beta hafnium. So we know all of these single phase regions, but nothing else is labeled. And so that's what we're going to do in this module, is label them. So we can label these blank regions. We actually know what's in them. And so we can label them because we know the single phases can only be bordered by other single phase regions. Single phase regions can only be bordered by other single phase regions at congruent points. So what we mean is that we saw that, let me go back. So this point right here is a congruent because it goes from the liquid to this hafnium vanadium 2. At the pure components, it goes from a liquid to vanadium, right? So that's congruent, and the same thing over here. So those are the only places at a point where a single phase region can be surrounded by another single phase region. Everywhere else, it has to be two phase. So here, this has to be two phase, this has to be two phase, this has to be, this has to be, this has to be, and so forth. All of them have to be bordered by two phase regions. So let me kind of work an example for you. This is a different one where, again, only the single phase are labeled. So we have alpha over in this tiny sliver. This line compound is beta, and this other line compound is gamma. So we know that this is the only region here where a liquid or a single phase region can be surrounded by others. So everything else, this, and this, all have to be two phase regions. And the way we get that is by what is around it, right? So in this region here, we look to what's to the left and what's to the right. So here, we know this to be a two phase region because we have a one phase region and a one phase region. So we know that alpha is to the left and beta is to the right. And so this has to be a mixture of alpha and beta. And then I did them in a different order, but this region here is surrounded by alpha on the left, liquid on the right. And so we know it's alpha plus liquid. Same thing here. Liquid is on the left in this case, and then beta is on the right. And so this is beta plus liquid. This, like I said before, is alpha plus beta because of what's to the left and right. This region here, you have to remember that these are lines, right? Line compounds. So this is another region, and this is going to be beta plus gamma. And again, I'm doing them in opposite order, but sorry for that. And then this one up here has liquid to the left and gamma to the right, right? So you're basically just filling in these regions based on what's to the left and to the right, because it has to be a mixture of what's to the left and to the right. All right, so in this next module, that's what you're going to do. You're going to do an example of that.